Welcome to today's class on vector analysis. Today we discuss limit of vector functions. Now we define limit of a vector function. Let r of t equal to f of t I plus g of t j plus h of t k be a vector function and L be a vector. We say that r has limit L as t approaches t naught, and we write limit t tends to t naught r of t equal to L if for every epsilon positive there exists a corresponding number delta greater than 0 such that for all t 0 less than modulus of t minus t naught less than delta implies r of t minus L is less than epsilon. That is, when t is coming closer to t naught, vector r of t is coming closer to the vector L. So if L equal to L1i plus L2j plus L3k, then limit t tends to t naught r of t equal to L precisely when limit t tends to t naught f of t equal to L1, limit t tends to t naught g of t equal to L2, limit t tends to t naught h of t equal to L3. So to find the limit of the vector function, it is enough to find the limit of the components. That is, limit t tends to t naught r of t equal to limit t tends to t naught f of t I plus limit t tends to t naught g of t j plus limit t tends to t naught h of t k. Now we do a problem. Let r of t equal to cos ti plus sin tj plus tk. Find limit t tends to pi by 4 r of t. Answer here, f of t equal to cos t, g of t equal to sin t, and h of t equal to t, and limit t tends to pi by 4 f of t. This is equal to limit t tends to pi by 4 cos t, that is equal to cos pi by 4, that is equal to 1 by root 2, and limit t tends to pi by 4 g of t, that is equal to limit t tends to pi by 4 sin t, that is equal to sin pi by 4, that is equal to 1 by root 2, and limit t tends to pi by 4 h of t, that is equal to limit t tends to pi by 4 t, that is equal to pi by 4. Therefore, L equal to, using this definition, L equal to 1 by root 2 I plus 1 by root 2 j plus pi by 4k. That is, limit t tends to pi by 4 r of t, that is equal to limit t tends to pi by 4 cos ti plus sin tj plus tk, that is equal to 1 by root 2 I plus 1 by root 2 j plus pi by 4k. So this is how we evaluate the limit of vector functions. Now define continuity at a point. So this is a definition. A vector function r of t is continuous at a point t equal to t naught in its domain if limit t tends to t naught r of t is equal to r of t naught. The function is continuous if it is continuous at every point in its domain. Now there is an easy way to check continuity. So a vector function r of t is continuous at t equal to t naught if and only if each component function is continuous at t equal to t naught. So you can have an example. Consider this function r of t is equal to cos t I plus sin t j plus tk. We have f of t equal to cos t, g of t equal to sin t, and h of t equal to t are the components of this function. And you know cos t, sin t and t are continuous functions since cos t, sin t and t are continuous. in the interval minus infinity infinity, or on R, we have R of t is equal to cos ti plus sin tj plus tk is continuous in minus infinity infinity. Now consider the second example. So consider this function g of t is equal to cos ti plus sin tj plus greatest integer tk. You know that cos t and sin t are continuous, but greatest integer function t is not continuous. Therefore, the function g of t is not continuous. The vector function g of t equal to cos ti plus sin tj plus greatest integer t k is not continuous, since greatest integer function t is not continuous in R. So this is an example of a function which is not continuous in R. Now we discuss derivatives of vector functions. Let R of t equal to f of ti plus g of tj plus h of tk, and delta r equal to r of t plus delta t minus r of t. Therefore, delta r is equal to f of t plus delta t I plus g of t plus delta t j plus h of t plus delta t k minus f of t I plus g of t j plus h of t k. So this is equal to f of t plus delta t minus f of t I plus g of t plus delta t minus g of t j plus h of t plus delta t minus h of t k. Therefore, limit delta t tends to 0, delta r by delta t is equal to limit delta t tends to 0, f of t plus delta t minus f of t divided by delta t into I plus limit delta t tends to 0, g of t plus delta t minus g of t divided by delta t into j plus limit delta t tends to 0, h of t plus delta t minus h of t divided by delta t into k. So from this you can see that this implies dr by dt, this is equal to, this is the derivative of f, this is the derivative of g, and this is the derivative of h with respect to t. This implies df by dt into I plus dg by dt into j plus dh by dt into k. This gives the definition of derivative of a vector function. So now you can define the derivative. A vector function r of t is equal to f of ti plus g of tj plus h of tk has a derivative or is said to be differentiable at t if f, g and h have derivatives at t. The derivative is the vector function r dash of t, that is equal to dr by dt. So that is equal to limit delta t tends to 0, r of t plus delta t minus r of t divided by delta t. So that is df by dti plus dg by dtj plus dh by dtk. Now we discuss what is meant by differentiability. A vector function r is differentiable if it is differentiable at every point of its domain. And the curve traced by r is smooth if dr by dt is continuous and never 0. That is, f, g and h have continuous first derivative that are not simultaneously 0. A curve traced by r is smooth if dr by dt is continuous and never 0. That is, f, g and h have continuous first derivatives that are not simultaneously 0. Now we do a problem. So let R of t is equal to t plus 1i plus t square minus 1j plus 2tk. Find dr by dt. So here f of t equal to t plus 1, g of t is equal to t square minus 1, and h of t is equal to 2t. Therefore df by dt, that is equal to 1, dg by dt equal to 2t, and dh by dt equal to 2. Therefore dr by dt is equal to df by dt I plus dg by dt j plus dh by dt k. So that is equal to 1 into I, that is I, plus 2tj plus 2k. So this is the answer to the problem. We will do one more problem. Problem number 2. Find dr by dt. So here again, here f of t is equal to 2 cos t, g of t is equal to 3 sin t, and h of t is equal to 4t. Therefore df by dt, that is equal to minus 2 sin t, dg by dt is equal to 3 cos t, and dh by dt is equal to 4. Therefore dr by dt is equal to df by dt into I, so that is minus 2 sin t I, plus dg by dt into j, that is 3 cos t j plus 4k. This is the solution. And that's all for the day. Have a nice day.